It stands on almost nothing. No natural island, no solid ground beneath it, just the Arabian Gulf. Yet this 321-meter giant would become one of the most recognizable buildings on Earth. But in 1994, where this hotel stands today, there was only open water. Dubai had a dream, but before engineers could build the tower, they had to build the land beneath it.
Behind me stands one of Dubai's most recognizable landmarks. But before this tower could rise, engineers had to create the island beneath it.
Dubai wasn't always the city of skyscrapers we know today. In the early 1990s, its coastline was still developing, and Dubai was searching for a way to put itself on the world's map. Architect Tom Wright designed a tower inspired by the billowing sail of an Arabian dhow, giving Dubai a silhouette unlike anything else in the world. But there was one enormous problem. The perfect location for this landmark was out at sea. And that meant the engineers couldn't simply build the hotel. They first had to build the ground.
Where impossible becomes engineering. Welcome to Engineora Labs.
But building offshore created a problem far bigger than the distance from the shore. There was no island here. Engineers had to create one strong enough to support a 321-meter tower while protecting it from the Arabian Gulf. The first challenge was the seabed. Instead of building on natural rock, engineers had to anchor the structure deep into the ground beneath the water. So they began driving massive foundation piles into the seabed, marking the first step toward creating an entirely new piece of land. But the piles alone weren't enough. The sea itself had to be controlled first, and that meant building a protective barrier around the future island.
The solution began with massive concrete piles driven deep into the seabed. But engineers couldn't simply stop there. They needed a foundation strong enough to carry a 321-meter tower weighing tens of thousands of tons. Hundreds of piles were driven deep beneath the water, creating an enormous hidden support system. Then came the next battle. The waves. Engineers surrounded the future island with a massive rock breakwater, creating a protective shield against the Arabian Gulf. But even that wasn't enough. The seabed was still unstable, and the tower needed a foundation that could withstand enormous loads. So engineers created a huge concrete foundation above the piles. The island was finally becoming strong enough to carry the impossible.
With the island protected and the deep piles in place, engineers could finally turn their attention upward. But the foundation itself created another enormous challenge. The concrete base would carry the entire 321-meter tower, so even small weaknesses could become catastrophic. Engineers built a massive reinforced concrete foundation, carefully connecting it to the piles below. Inside that foundation, an intricate network of steel reinforcement locked thousands of tons of concrete together. But there was another enemy nobody could see: heat. Dubai's extreme temperatures could cause freshly poured concrete to heat up, crack, and weaken. So engineers had to control the temperature from the inside. Before the tower could rise, they had to make the foundation virtually bulletproof.
The foundation was finally taking shape. But engineers still faced the biggest challenge yet: building a tower that could survive the forces of the open sea.
The foundation was ready. Now the real tower could begin. But Burj Al Arab wasn't designed like an ordinary skyscraper.
Its huge sail-shaped form would constantly face wind, pressure, and twisting forces from the Gulf. Engineers needed a structure that was incredibly strong, yet light enough to rise hundreds of meters above the water. Their answer was a massive steel exoskeleton. Instead of hiding the main structure inside the building, they placed much of it outside. And that steel skeleton would become the hidden framework that gave the Burj Al Arab its extraordinary shape and kept the giant sail standing.
But creating the steel skeleton was only the beginning. The Burj Al Arab's design pushed engineers into another extreme, a huge open atrium surrounded by enormous structural forces. The steel frame had to be assembled with incredible precision, because even small alignment errors could affect the entire tower. Piece by piece, massive steel sections were lifted hundreds of meters above the Gulf and connected in mid-air. Then came one of the project's most dramatic challenges: the 27-meter cantilevered restaurant. It would project far beyond the main structure, appearing to float above the Arabian Gulf. And with nothing directly beneath it, engineers had to make the steel carry the entire load back into the tower. It wasn't just architecture anymore. It was a giant structural balancing act.
But the structure was only half the battle. Now engineers had to turn that enormous steel skeleton into the Burj Al Arab's iconic sail. The facade couldn't be an ordinary glass wall. It had to cover a huge curved surface, survive Dubai's intense heat, and handle powerful Gulf winds, while remaining light enough for the structure. The solution was a massive PTFE-coated fiberglass fabric facade. Thousands of square meters of white membrane were prepared in carefully engineered sections. Each panel had to be positioned and tensioned precisely across the steel frame. And once installed, the fabric would transform the exposed skeleton into the unmistakable white sail that made Burj Al Arab an icon. But the white sail wasn't just about appearance. Behind that fabric was a carefully engineered system designed to control light, heat, and the brutal Gulf climate. The facade had to allow daylight into the building while reducing the impact of Dubai's intense sun. Engineers also had to make sure the enormous membrane remained stable as winds pushed against it. Every section was tensioned and secured to the surrounding structure, turning the fabric into a carefully controlled architectural skin. And as the final panels came together, something remarkable happened. The Burj Al Arab stopped looking like a construction project and started looking like a giant sail rising from the sea. The outside was finally taking shape, but inside, engineers faced another enormous challenge. Behind the famous sail was a 180-meter-high atrium, creating one of the most dramatic interior spaces ever built into a hotel. Every floor had to connect safely around this massive open void, while mechanical systems, elevators, plumbing, and electrical networks were fitted into the complex structure. Then came the transformation from engineering project to luxury hotel. Workers installed elaborate interiors, towering decorative elements, and thousands of carefully finished surfaces. Even the smallest details were designed to feel extraordinary. Gold leaf covered parts of the interiors, adding a level of luxury that matched Dubai's ambition. And after years of construction, the empty steel skeleton had finally become something completely different. By 1999, the construction site had disappeared. In its place stood a 321-meter tower, rising from an artificial island in the Arabian Gulf. What began as open water had become one of Dubai's most recognizable landmarks. The Burj Al Arab brought together an artificial island, deep foundations, a massive steel exoskeleton, a 27-meter cantilever, and its enormous sail-shaped facade. But its story was never only about luxury. It represented Dubai's ambition to build something the world had never seen before, and to make that ambition visible from miles away. Today, the Burj Al Arab remains a symbol of that vision. Because sometimes the most impossible structures begin with nothing more than open water and an idea that refuses to stay impossible.